So in this problem we have a board of length 4 meters and mass 30 kilograms is being carried horizontally. So we have this board that's horizontal, and we know that its whole length is 4 meters and its mass is 30 kilograms. And there is a man and a woman carrying it, and the man is applying a force of 98 newtons upward at one end of the board. So I'm going to put it over here. And we want to know where should the woman apply a force of 196 newtons on the board, so that we're in conditions of static equilibrium. Alright, so that means that we need to use our problem solving steps. So we're going to pick an object. Our object is going to be the board, because that's what all the forces are acting on. And now we need to label all of our forces. So I've already labeled 2 of them, and I've appropriately labeled this one's location. I know that since this is one end of the board, the woman has to apply the force somewhere over here, but I don't know exactly where, so I just picked an arbitrary spot. So there's one other force acting in the system, and that is the weight of the board itself. And remember, for a homogeneous symmetric object, so anything homogeneous, symmetric, and extended, we're going to apply that force at middle. So the force of gravity of the board is going to be applied here in the middle. Now I'm fairly certain that the woman needs to be on the other side of the middle of the board in order to balance this force out. So we're going to assume that if we get any funky answers, maybe that assumption was wrong, but it makes the most sense. Usually when you carry something, you want one person at one end and one person near the other end. So balanced on either side of the pivot point of the object, or where the weight is applied. That usually makes the most sense for carrying things. Alright, so I'm going to set my torques. We have a torque due to the man, a torque due to the weight of the board, and a torque due to the woman. And I'm going to sub in. Alright, so now we need to decide where to set r equals 0 at. Now normally the strategy is to put it at some place where we don't know a force, and we don't actually want to find that force. But in this particular problem, we know this force, and we can find this force because we know the mass of the object. Which means that I could put the r equals 0 at any point of the board as long as I have the ability to figure out the lever arms relative to it. So I'm going to make my life easy, and I'm going to put r equals 0 right here at the other end of the board. So that means that this lever arm here of the woman is my unknown. This would be half of the length of the board because it's applied at the center. And then this one here, so this was RG, RM is going to be the full length of the board. And we also need to decide whether they're positive or negative. So this one applied upward like this. That is clockwise, so it will be negative. This one is applied down around like this, so it will be counterclockwise, so it will be positive. And then the man is applied up like this around the center point, which is clockwise, so it'll be negative. Alright, so now I can plug my numbers in. So I get a negative 98 newtons times 4 meters plus 30 kilograms times 9.8 meters per second squared plus a negative 196 newtons times our unknown. And so when we rearrange this, we should get that r equals 1 meter. So the woman needs to apply the force 1 meter in from the right end of the board. Now if you had picked r equals 0 at any other point, that would change which torques are negative or positive, and it may change your number. So the distance between here and here would be 1 meter, again, because between here and here is 2 meters. But if you put it over here, you would get your answer as 3 meters, because the distance between here and here is 3 meters, because the distance between here and here is 1 meter. So 4 minus 1 would be 3. So you may get a different value based upon where you set r equals 0 at. So any lever arm distance for this section is going to be based upon where you set r equals 0. So we may get two different numbers, but we both have the right answer because we're putting the 0 point of our meter stick at a different spot.